So for this section, what we'll look at is we'll look at the manipulations of equations and how to answer these kinds of questions. So with these ones, the type of question you'll get will give you two equations, as you can see here, and these equations will come complete with their delta HR values. You'll be expected to manipulate these equations in order to find the delta HR value of these. So how does this work? When we manipulate equations, we can do three things. We can multiply by a particular value. So for example, if I had A plus B formed C, and the delta HR was, let's say, plus 100 kilojoules per mole, right? What we could do is we could turn this into 2A plus 2B forms 2C, or we can do it to 3A, 3B, 3C, 4A, whatever number you want. And what you do here is you would change the delta HR value correspondingly by multiplying the delta HR value by the same factor. So over here we have 2A plus B forms C, and this has become 2A plus 2B, 2C. So the delta HR value is now going to equal plus 200 kilojoules per mole. Okay, so we can do that. The second kind of thing we can do is we can go and we can reverse equations. So what this means is, let's say I have a look at this equation here, 2A plus 2B forms 2C. What I could do is I could go and I could convert this equation into, let's say, the opposite equation. So that's 2B, sorry. So that's going to be 2C forms 2A plus 2B. So we can see that this is where we've swapped around the products and the reactants to the opposite sides. So the reverse equation is going to have a delta HR of negative 200 kilojoules per mole. Okay, nice. And the third thing that we can do is we can go and we can add equations together. So over here, the third thing we can do is we can add equations. And so for example, what I could do here is I could get this equation here, let's take this equation 1, and this equation in blue over here, equation 2, and add the two together. So what does that mean? When we add equations together, what we're going to do is we're going to get the reactants of one and add them, the reactants of one, so A plus B here, and add them to the reactants of the other, and then get the products of one, and then add them to the products of the other. So if we add these two equations together, what are we going to get? Let's have a look. So in equation 1, we know the reactants are A, and in equation 2, the reactants are 2C. Sorry, A plus B for equation 1, and 2C is the reactants for equation 2, and the products for equation 1 are C, and the products for equation 2 are 2A plus 2B. Let's get some space over here. Okay, we'll leave it. So actually, let's keep this back for a moment. What we can now do is we can simplify this equation. So we see that there's 2A and 2B on the right, and there's A and B on the left. So we can go ahead and cancel these out. And that makes that A and B. So we've removed A and B from both sides. And also there's 2C on the left and just 1C on the right. So we can cancel out this C here and then cancel out the 2 there. So what we're left with at the end of the day is we're left with this. C forms A plus 2B. Sorry, C forms A plus B. And what is the delta HR of this? The delta HR is going to be equal to the delta HR of the first equation, so plus 100 kilojoules per mole, added to the second equation, negative 200 kilojoules per mole. So the delta HR at the end of the day is going to be negative 100 kilojoules per mole, like this. Okay, and if we have a look, which is the opposite of this one here, because remember this was A plus B from C. That comes to 100 kilojoules per mole. So the reverse of this, C forms A plus B, would be negative 100, and that's what we're getting over here. Cool. So how do we apply this to this particular question that we have here? The way we do this is like this. First of all, you want to determine what manipulations you'll do. So you do this by thinking about the unique chemicals. So the unique chemicals are going to be what? Chemicals where you can only find them in one place in one equation. So for example, if I have a look over here, there's 2 carbon dioxides, or the chemical that we're interested in is carbon dioxide. If I take a look over in the given equations, carbon dioxide only ever comes up here. So I'll consider it a unique chemical. Also, another unique chemical would be carbon monoxide. CO is found only here and nowhere else in the other 2 given equations, and CO is only found over here. Oxygen is not going to be a unique chemical because I can find oxygen here and I can also find oxygen here, so it's not a unique chemical. Similarly, carbon and carbon are found in multiple equations. Those are not unique chemicals. So why do we care about unique chemicals? Because unique chemicals, so the unique chemicals will tell us what type of manipulations need to be done. And the 2 ways they tell us is by whether or not they are a product or a reactant, or whether or not they are going, what the coefficient is in these chemicals. So let's have a look over here. If I take a look at, let's say, 2 carbon dioxides. Carbon dioxide identified was a unique chemical. So if I take a look over here, carbon dioxide in the given equation is a product. Carbon dioxide in the desired equation is also a product. So that's good. But we can see there's a 2 in front of carbon dioxide in the desired equation. So that makes me think maybe I need to multiply this first equation by 2. Also, if I take a look at, let's say, if I take a look at carbon monoxide, and I take a look at carbon monoxide over here, we can see that carbon monoxide in the desired equation has a 2 in front of it, and carbon monoxide in the desired equation is a reactant, whereas carbon monoxide in the given equation is a product. So that makes me think that maybe I need to reverse this equation. Okay, so let's go ahead and make these changes now. So what I'll do is I'll multiply this by 2, so that 2C plus 2O2 forms 2 carbon dioxide, and the delta HR is going to be, in this case, doubled. So it's going to be minus 200 kilojoules per mole times 2. So in other words, what that's going to give us is minus 400 kilojoules per mole. Okay, and over here, let's go ahead and reverse this equation. So when we reverse this equation, this becomes 2CO forms 2 carbon plus an oxygen, and the delta HR value is going to be reversed. So we change the sign of the delta HR value to become positive 120 kilojoules per mole. Okay, so now we have these 2 new equations. What can we go ahead and do? We can go ahead and add these 2 new equations together. So I'm just going to make a new screen and we can use the bottom of the screen. So what we can do here is we can add the 2 new equations together and see what happens. So we've got 2 carbons plus 2 oxygens forms 2 carbon dioxide. So we see that that's the top equation up here. Over here, that's the top equation here. And what we'll do is add that to the bottom equation that we've manipulated. So 2 carbon monoxide plus 2 carbons plus oxygen. So what that'll give us is what? So 2 carbon monoxide forms 2 carbon plus oxygen. So when we add these 2 equations together, what do we get? We get 2 carbons plus 2 oxygens plus 2 carbon monoxides forming 2 carbon monoxide. Sorry, my bad. This is forming 2 carbon dioxide. Whoops. So it forms 2 carbon dioxide. So it's carbon dioxide here, plus 2 carbons plus 1 oxygen. Okay. So this equation here is our equation that we've added together. So now we can start by cancelling out things. So we can cancel out these oxygens here, and then we can cancel out these 2 carbons here. And what that leaves us with is 2 carbon monoxide plus oxygen. So there's 2 carbon monoxide here, and the oxygen is over here, and that forms 2 carbon dioxide, right? And that's our desired equation, as we can see here. So this desired equation here is the same as the desired equation, the equation that we've gotten over here. And the delta R here is simply going to be, remember when we add 2 equations together, we add the delta HR values. So let's go ahead and look at what these delta HR values are. We said that the delta HR value was this here, so 120 kilojoules per mole, as well as this one over here, which is minus 400 kilojoules per mole. So the delta HR of our final equation is going to be minus 400 kilojoules plus this 120 kilojoules. So that's going to give us what? Negative 280 kilojoules per mole. Okay, and there we go. There's our final answer. So we can see that the enthalpy of reaction, so we clear this, the enthalpy of reaction of this final equation over here is going to be delta HR equals negative 280 kilojoules per mole.